Hello everyone, welcome back to the third tutorial video on our quest to learning programming languages through or by using Python. So let's do an overview of the last two previous videos, what we were able to cover. In the previous two videos, we looked at the definition of a computer as a general purpose device that can be programmed to carry out arithmetic and logical operations. Then we also looked at the basic parts of the computer, the hardware and the software, and we said the hardware part of the computer are the physical parts of the computer that you can touch and feel as a user, and the software aspect of the computer, it's the part of the computer that you can only see but you cannot touch. Then we also looked at the concept of application with respect to where we are driving at how to program on Python or how to approach any programming language of your choice, what programming it's all about, and the end result. We looked at that's application software or program as a means of accomplishing a specific task. Every program or application or software that is designed or developed has one specific task that it will achieve, and if you're using the computer to achieve that specific task, then you are applying that particular task on the system. The whole concept of what application is all about. If you want to draw, I gave an analogy that if you want to draw and you're using the computer to draw, the application with which you're using to accomplish that specific task of drawing is what you are applying. That application, for instance, the one that is so rampant over here, Corel Draw. Now you are applying drawing on the computer through an application called Corel Draw. Okay, so you are applying that task, you are applying that drawing task on the computer, hence the name application. And if you want to do word processing to prepare your resume, you are going to use a common application which is rampant also over here, the Microsoft word processor. So you are also applying word processing on the computer. So we could now substantiate the definition of a computer that is a general purpose device, okay, that can be programmed. Okay, so we're able to establish that fact, that concept. Then we looked at the fundamental approach to learning any programming language, and I went on to say, whenever you want to verge into any programming language, one of the first things you need to consider is for you to identify the data type that the programming language supports. It's key. The data types help you to understand the kind of data the programming language will be able to manipulate, the kind of data the programming language will be able to accept, store, as the case may be. Then we looked at one or two features of a data type. We talked about the data type. I used the analogy of cup and jug. Okay, data types of a programming language are key. Okay, basic data types that we have across almost all programming languages are: we have the integer data type or int, we have the floating point data type. Okay, we also have the string data type as well. Now each of these data types are meant to handle different data. Okay, an integer data type will only handle whole numbers, okay, like 5, 6, 7, 8, 9 as the case may be, 100, there are no fractional parts. Then the floating point data type would handle numbers that have decimal parts, that is 6.09, 5.09, 3.2, 2.5. These are floating points, and there are examples of the floating point data type which the programming language will be able to handle. Then string, when we talk about string, we are saying alphanumeric characters and including special symbols, okay, and they should and special symbols. Then we looked at understanding what syntax is all about, the rules that governs that programming language. If you want to make a valid statement in that programming language, you need to know the rule that is involved, that you need to apply to be able to make a valid statement in that programming language. And I also use the English language as an analogy, that in English language we have parts of speech, the noun, the verb, and all sorts. And the rule for you to make a sentence in English language is that that sentence must have a subject and that sentence must have a predicate. The subject there is the noun, okay? The predicate there is the verb and the other parts of speech, as the case may be. So we were able to establish that understanding as well in terms of syntax rules in creating making a valid statement in a programming language with respect to Python. And we said in Python is more flexible because it gives the user, it gives the programmer rather, the leverage to declare a variable or an identifier without prefacing it with the usual or conventional int word, string word, or str character, or float character, or double, as the case may be. Okay, so Python has that flexibility. The interpreter of Python, it has this intelligence, okay, or intelligence, as the case may be, to be able to define a variable or an identifier with respect to the kind of data that is assigned to it. Okay, so we're able to establish that fact. Okay, then we also were able to look at variable names, identifiers, what they are and how they are formed. Okay, we established the fact that a variable is a temporary memory location that the programmer reserves for it to be used to manipulate whatever data that it's required to be manipulated. Okay, and usually variables are declared as of data type. Okay, so that's why data types of a programming language are very key. Okay, so we were able to further establish under identifiers and or variable names that if you want to name a variable, there are certain things that you need to take into consideration. That variable name must not start with a number, it must not have special characters like in between it must not have an @ sign, it must not contain a percentage sign, it must not contain an ampersand sign, as the case may be. However, you are allowed to use an underscore, okay, to separate, to join two words together, as the case may be. And we're also able to establish a fact again under variable names or identifiers, that there are keywords in every programming language. Okay, so in Python that we're using to consider our study, in Python there are keywords that you should not use and you should be aware of them. You should identify them. These words are reserved words. They have special meaning to the interpreter or the language, as the case may be. So you should not use them as your identifier or your variable name, as the case may be. And we looked at things like print, the word print. We looked at the word continue. We looked at the word none. We looked at the word def, del, as the case may be. We mentioned them. Okay. Another thing that we looked at is how to output is the output statement. We're able to identify the output statement of the programming language Python and how it is used. We also were able to establish an operator in the output statement, okay, the comma operator, the essence of the comma operator in the output statement. Then lastly, we also looked at the input statement. How do we get an input data from the user during runtime? When the program is being executed during runtime, we can extract or receive an input data through the basic input device, which is the keyboard. Then we manipulate that data depending on the data type, okay, and the kind of operation that has to be carried on that, executed on that particular data that we received from the user. Okay, that is a nutshell. Today we'll be looking at, we'll be identifying arithmetic operators in Python programming language. We'll be identifying compound operators in Python programming language and logical operators, then decision controls in Python programming language, and how they can be used. We'll be looking at live examples on these 4 areas in Python programming language. So let's start. Okay, so arithmetic operators are basic operators in mathematics. As we can see on the screen there, the addition operator, the subtraction operator, the multiplication operator, the division operator, the integer division operator, the modulus operator. Now, I want you to give a closer attention to what I'm going to say. Basically, the computer does arithmetics and logical operations. The computer, what we know as multiplication or division, it's still the same thing as addition and subtraction, as the case may be. Now, the addition operators is to add 2 values together or to add 2 strings together, as the case may be, while the subtraction operator is to find the difference between 2 values or 2 operands, as the case may be. Now, when we get to the multiplication and division operators, I'm going to explain a concept that the microprocessor uses, okay, to accomplish multiplication and also to accomplish division. However, let's look at the addition operator and the subtraction operator. Let's go to Spider ID here. Now, if you want to add two integers at design time, all you need to do, the syntax in addition operation on Python programming language is simply this: the variable name, the assignment operator, because we must make a valid statement, and that valid statement must conform with the syntax. So a variable name, say num5, an assignment operator, then two or more operands. Okay, two or more operands, whatever it's on the right hand side of this assignment operator, it's known as operand in an arithmetic problem. Okay, so we have up here, we have num1 being assigned the integer 5. Okay, then we have down here, permit me to move this up here, we have num3 as integer what? 6. And we say num1 add num3. Now this is a valid statement in Python rather, and this is an expression. Okay, the expression has two operands. This is the first operand, this is the second operand, and we have an arithmetic operator in between these operands. Okay, so what this statement simply means is that the Python interpreter should reference the memory location that has the name num1, okay, and also reference the memory location that has the name num3. Whatever is contained in num1 should be added to whatever is added with whatever is contained in num3. The solution should be assigned to another memory location that is referenced by the name num5. Okay, that is simply what this statement is all about. Okay, so we can as well discover the results by changing this to num5. Okay, so by the time the interpreter carries out this evaluation on the right hand side, whatever the result is, it will store it in num5, the memory location referenced as num5, then we will output it on the screen. So let's see what we have there. Okay, so num1 is holding the value 5, num3 is holding the value what? 6. Okay, these are integers, right? Okay, so 6 plus 5 will give us what? 11 down here. Okay, so this is just a typical example of adding two numbers at design time. Okay, at design time, as I'm designing this program, I supply this data at design time. For instance, we want to ask the user of your program to impute two integers or two values. We may not know what those values are anyway. However, we can still be able to, we can still instruct the user of our program to tell the user the kind of value that is expected to be imputed or received by or supplied at runtime anyway. Before we do that, let's also look at a scenario where we want to add two floating points, as the case may be. Okay, so we just had the addition operation carried out on two operands that are holding integer values. Okay, so let's look at a situation where the operands are of floating point as well. So we say num2 plus say num4, create another num4 is assigned the value 3.8, okay, which is a floating point. Okay, so what we'll have there now is num4. Okay, so I'm only going to, okay, I'm going to print both results out, okay, while this will be num6. Okay, so here we are carrying out an operand, an arithmetic addition operation on two integer operands. Then on this other line, on line 11, we are carrying out also an arithmetic addition operation on two floating points, as the case may be. Then we'll display their result. Now note that I had to create two print statements on two different lines, on line 13 and line 14, okay, because of what I want to display. So I'm going to run this program and let's see what the results are. So we have the up one, the first result as 11, then we have the second result as what? 7.89. Now take note, if I do something of this nature, if I take off this, then instead of adding two integers together, okay, then I want to add a floating point and an integer. Okay, I change this to num4. Let me take off this. So num4 is 3.8, while num1 is an integer. So this operand is a floating point, this operand is an integer, then the identifier that the result of this operation will be stored in is an integer. It's of type integer. Let's see what the result would be. So I'll run the program, and what do we have there? We have 8.8. So by default, we could see that the identifier, we could see here now that the Python interpreter was able to give this num5 the data type float because of the result that was gotten from num1 plus num2, because by the time you add 5 plus 5, which is an integer, plus 3.8, the result will be what? 8.8. So the result now determined what this variable num5 data type is. All right, let's say we want to add two floating points, which we've also looked at. If we so the essence here is that the interpreter has the ability to detect, okay, what data type an identifier would be based on the result or based on the value that is what assigned to it. So let's also look at a situation where we want to carry out an operation, an arithmetic plus an addition operation on two strings. And what we have here, we are still going to maintain num5, we won't change it. We have name1. You can as well carry out, do this, and it's a valid operation in Python programming language. Okay, so let's see what the result is. We want to add these two strings. These are strings, right? Okay, name1 is containing the string martin. Name2 is containing the string mizu. Okay, we want to add them together. Okay, so what do we have there? martinizu. Okay, it's added together, so it's a valid operation as well. Okay, if you want to space it, then you can create a space in the, you can create a blank space or a white space on this string here of character. If we run that program again, we now see that we have what? Martin space izu. Now this space is this space you find in between Martin and izu is this space you will find on line 5, okay, after n. Okay, so these are some of the things that we need to note about mathematic addition operator. We can as well do something like this. Let's see if it's going to throw an error. Okay, let's say num4, and let's run it. Okay, so can only concatenate string, not float. Okay, so that is what I want to bring out. Now, when you are adding two strings together, it is called concatenation. When you're bringing two strings together with the addition operator, it's called concatenation. So the Martin-Izu that we're able to get here, name, because there are scenarios, live scenarios where you would want to do this. Okay, this operation is going to, this name1 and name2 will be concatenated as we saw there. Okay, so Martin space izu has been concatenated together. So it's, you should not add a string with a floating point or an integer, because the interpreter is going to throw an error at run time. Okay, so having got that, let's move on to the next operator, the subtraction operator. So num1 all right, so num1 minus num3 minus num1. We're looking at the subtraction operator. Okay, so it's simple as well. These are two operands, then we have the subtraction operator in between them. Okay, so what this statement is saying is that the value that is in the memory location that is referenced as num2 and the value that is in the memory location that is referenced as num1, let the interpreter find the difference. Okay, find the difference between the content in num3 and the content in num2. The result should be stored in num5. Then we output the statement. Okay, 1. So when we talk about subtraction, we are looking at difference. What that simply means is that when we talk about difference, we are saying here that 6 minus 5 is equal to 1. Okay, now what this statement means, when we say 6 minus 5, we are saying what is the difference between 6 and 5. The difference between 6 and 5 is what? 1. Because if you add 5 plus 1, you will have the result what? 6. So another way to interpret this statement, 6 minus 5, is what? The difference between 6 and 5. The difference between 6 and 5 is what? 1. If this were to be 8, the difference between 8 and 5 is what? 3. Are we together? Now, if you have this understanding, it will enable you to know how the computer handles division process. It will also help you to understand the way the computer handles multiplication operations. Okay, what the computer does is addition and subtraction, basically. Okay, because multiplication is repeated addition, while division is repeated differences. We'll get to that, which is one of the reasons why the computer is defined as a calculator. The computer is defined as what? A calculator. We'll get to that. So in our example here, we could see that the difference between the content of num3 and the content of num1, the difference will be stored here, which is what? 1. If we come down here, our display screen. Okay, so that is for that. Now, in other programming language, if you do something like this, you say num3. Num3, what's the difference between num3 and num4? Now, the result will eventually be what? A floating point. But in other programming language, the result may not be a floating point. The result may return an integer, but Python has the flexibility to determine the variable name, the variable type, okay, that the result will be stored with respect to the results data type, whether it is an integer, whether it is a floating point, or whether it is a string, as the case may be. So let's see what this result will be. So we could see here that the result is in floating point, which is 2.2. So the difference between 6, num3, the difference between 6 and 3.8 is what? 2.2. So this is the flexibility feature that Python has over some other programming language like C++ in terms of like C++ and C#, or even Visual Basic. Okay, this is the flexibility, including Java. This is the flexibility, so it's an added advantage. Now the interpreter has the ability to discern or decipher. It's not as rigid as it is in those programming languages that I mentioned, where you have to keep track of every arithmetic operation, because if you don't keep track of the values, your end result will be what? Wrong. Okay, but Python has this flexibility where it can determine, okay, the issue of truncation, which is common in those other languages, may not necessarily apply here, because Python has the ability to discern or decipher what the variable data, the variable name or identifier data type with respect to or vis-a-vis the value or the data type that is to be assigned to the identifier. Are we together? All right. So we'll move on to the next operator, which is addition. Which is multiplication. Multiplication could be simply referred to as multiple addition. Okay, so if we go back here, if we say 3 times 5, what do we mean? The meaning of this expression is how many times are you going to add the value 3? Or if you add the value 3 into 5 places, you will get the result. Or if you add 5 in 3 places, the result should be 15. If you add 3 into 5 places, the result would be what? 15. So multiplication usually in mathematics has this specific and unique feature called associativity. Whether you take it from the right, whether you take it from the left of the operands, in between the two operands, okay, your answer will still be what? The same. So let's look at the two scenarios of 3 times 5, what it really means. Okay, so what this means is 3 plus 3 plus 3 plus 3 plus 3. So we have 3 here, 1. We have 3 here, 2. We have 3 here, 4. We have 3 here, 5. We have 3 here, what? 6. 1, 2, 3, 4, 5. 3 here, 5. The end of it is that this will be equal to what? 15. 3 plus 3, 6. 6, let's break it down. The first one, 3 plus 3 will give us what? 6. Then we come down again, 6 plus 3, that's the third 3, which is this one, will give us what? 9. Then we go to the fourth one. 9 plus 3 will give us what? 12. Then the last one, 12 plus 3 will give us what? 15. Okay? So the first 2, 3 here will give us what? 6. Then this result 6 plus this third 3 will give us what? 9. Now this result 9 here with this fourth 3 will give us what? 12. Now the result 12 with this fifth 3 will give us what? 15. So multiplication is simply repeated what? Addition. And that is what the computer does. Okay, when you say 3 times any, when you say 2 operands are multiplied together, it picks irrespective of the operands. Okay, it can pick 3 and add it into 5 places to give you the result, or it can pick 5 and add it into 3 places to give you the result. So that is the concept. That is the concept of multiplication. So let's look at the other associativity of let's look at the associativity feature of a multiplication. So we can as well say here that 5 plus 5 plus 5 plus 5 will give us what? Let's look at what we have there. If we say 5 plus 5, 5 plus 5, we'll have the result what? 10. Then we say 10 plus 5, we have the result 15. Okay, so whether we go this way or whether we go this other way, we should still have the same result. That's what is called associativity. Whether you take it from this operand of the operator, it will still give you the same result. Whether you start from this operand of the operator, it will still give you the same result. So 2 things that we've established here. The first one is multiplication in computing is, or in mathematics in general, is repeated addition. So also division in mathematics is repeated differences or repeated subtraction, and that is what the processor does. Okay, so we've been able to establish the fact that 5 plus 5 plus 5 will give us what? 15. So 5 is in 3, 1, 2, 3, which represents this one here, while here we have 3 plus 3 plus 3 plus 3 plus 3 gives us what? 15. So 3 will be repeated 5 times. So 1, 2, 3, 4, 5. Are we together? So that's the concept about multiplication. So if we say here, we are saying num3, which is holding the value 6, multiplied by let's say num1, okay, multiplied by 5, we are going to have the result as what? 30. Okay, 30. Okay, so what this simply means is that add 6, the value 6, 5 times, you are going to get the result. Okay, add the value 6 5 times. Let's look at it. Add the value 6 5 times. 6 times 5. So what this simply means is that repeat 6 5 times. 6 1 6 2 6 3 6 4 6 5. Okay, then you insert your addition operator, addition operator, addition operator, addition operator, addition operator, addition operator. So 6 plus 6 is 12. 6 plus 12 plus 6 is 18. Okay, 18 plus 6 is 24. 24 plus 6 will give you what? 30. Okay, do you see how the computer does the operation? Okay, same thing with floating points. I just want to bring that understanding. So the next operator we'll be looking at, oh, it's almost an hour. The next operator we'll be looking at is the division operator. Okay, now the division operator, which is your forward slash. Okay, now this division operator is key. There are two. If we look at what we had there, the single forward slash division operator is known as a floating point what division operator. That is, if you want to divide floating points, the operands or the values that you want to operate, that you want to evaluate, if they have decimal parts, then you should use this division operator. But if they don't have decimal part, then you should be using this division operator. So let's look at their difference. Okay, so if we say let's change, if we say this operator is for floating points, so we are required to say num 4 should be divided by num 2 rather should be divided by num 4. Okay, so we're saying that the content that is found in the memory location of num 2, which is what 4.0, we should divide that with the content that of num 4, which is 3.8, and we should output the result. Okay, so the result there is 1.076 blah 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 blah. So this, you discover that this is a floating point 3.0, this is also a floating point. Now if we change this operator to the double forward slash operator, let us see what will happen. Okay, so it is also key. Let's take note of this. Now this operator, the double forward slash operator, is supposed to be used for division of what? Integers and not floating points. But the operands that we have on both sides of this operator, they are what? Of type floating points. Let's see what the result will be. Now, what do we have there? Now we have the result here as 1.0. what can you tell from this? You could discover that these decimal parts, okay, 7, 6, 3, 1, 5, 7, and all that have been what truncated, which will further cause your results to be what erroneous. Your result will not be what correct, because this sign, this operator is supposed to be used with just integers only. Okay, so the operator has ended up truncating these other floating points, these other decimal places. Okay, hope we can see the difference. If we make it 1, the single division operator, we could see the answer there. Then if we use the integer division operator, we could see also the result 1.0. So this is key. We should take note of this. Okay, so if we are to change this to the normal operands, okay, say num3 is divided by num1. Okay, so let me explain. We were able to explain the concept of multiplication, what the processor does behind the scene. Repeated when we say multiplication, the processor will just add a particular operand, okay, for the number of the number of time of the other operand as we looked at it. Now let's look at division. What is division? Now we were able to establish the fact that when we talk about subtraction could be interpreted as finding the difference between two numbers or two operands, whether they be integer, whether they be float. Okay, so subtraction is different. What is the difference between 5 and 6? The difference between 5 and 6 is 1. Okay, now when we say 6 should be divided, when we say 6 here should be divided by the value, the integer 2, what does that mean? Let's go back again to that analogy and look at what we have there. When we say 6 divided by 2 in mathematics, okay, this sign here is division in mathematics. We are not on the IDE, so I'm using this, okay, in pure maths, or let me use it. What this is integer operator division with respect to Python. When we say 6 divided by 2, or we say num3 divided by num1, okay, so that we can flow together. Now what we are simply saying here, or what the processor will do here, it's going to find out how many times you can subtract 2 from 6. I repeat again, when you say 6 divided by 2, the way the processor looks at it is how many times, how many 2's do we have in 6? To put it in simple terms, how many 2's can we find in the value what? 2. Okay, so let's do it, and that will be accomplished by this 6 minus, if we say what this result will evaluate to is 6 divided by 2, the result will be 3. How did the computer, or how did the calculator come to this, arrive at this result? This is simple. 6, the difference between 6 and 2 The difference between 6 and 2 is what? 4. The difference between 4 and 2 is what? 2. The difference between 2 and 2 is what? 1. Okay? Then it's 0 rather, sorry, it's 0, 0. The evaluation stops. Now, what do we have there now? We could see that we have 2, 1, we have 2, 2, we have what? 2, what? 3. That was how it arrived at what? This value, what? 3. So, division is finding the difference of the left-hand operand, how many times the left-hand operand can be found in the right-hand operand. That is, this is 6, this is 2, in between the operand, in between the operator. Okay, so how many times will 2 occur in 6? That is what this statement is all about. How many times 2, how many 2's can we find in 6? And how many 2's can we find in 6? We use the difference, okay? We said the difference between 6 and 2 is what? 4. We can still see that we can find the difference again. The difference between 4 and 2 is what? 2. Then we did the last operation. The difference between 2 and 2 is what? 0. Because they are equal, so there is no difference between 2 and 2. But there is a difference between 4 and 2, which is 2, and there is a difference between what? 2 and 6, which is 4. So we will concentrate on this. We have 2 in 6, 1. We have 2 in 6, 2. We have 2 in 6, what? 3. So if we say 3 times 2, we will still have the result as what? 6. If we add 3 2 times, we will have the result as what? 6. If we add 2 3 times, if we add 2, when we say add 2 3 times, we say 2 plus 2 plus 2. So we have 2 here. We have 2 here, 1. We have 2 here, 2. We have 2 here, 3. Okay? The result will give us what? 6. Okay? If we add 3 2 times, if we say 3 plus 3, 3 plus 3, the result will give us what? 6. Okay? Because we have 2 here, 3 here, 1, occurring 1 once. We have 3 here occurring the second time, which is 2. So 3, instead of repeating 3 times, instead of repeating 3 times 3, you just say 3. Instead of repeating 3 plus 3, another way you can rewrite it, instead of repeating 3 plus 3, another way you can rewrite it is 3 times 2. Instead of repeating 2 plus 2 plus 2, another way you can rewrite it is 2 times 3. Okay? It's shorter for you to say 3 times 2. Okay? Or it's shorter for you to say 2 times 3 than writing 2 plus 2 plus 2. When you can replace this whole 2 occurring 3 times with the value what? 3. So that is what division is all about. There is no magic. So what the computer usually does is addition and what? Subtraction. For the case of division, it's simply subtraction repeated, how many times a particular operand could be subtracted from the other operand. Okay, when we talk about multiplication, how many times a particular operand can be added, okay, as the case may be. So that is that for division and multiplication, addition, and subtraction. So the next operator we will look at, the next operator there is the modulus operator. Now the modulus operator, which is the percentage sign, but it's called modulus operator anyway in programming languages. Okay, the modulus operator will return at the end of the evaluation, is going to return the decimal part of that operation. So let's see what we have here. Let's type modulus operator, and we have num4, num2, and num4. So this will be interpreted as num2 modulus 4. Okay, let's see what the result will be. Okay, so we could see that it returned the decimal part. Okay, it returned what? The decimal part. Let's also get a print statement and do the same for, let's say, num6, right? Num6 is assigned num2 floating point division operator num4. So let's see the difference between these two. The operands are the same, but the operators are different. Let's see their results. Okay, so we are having the same results. Let's see. Let's take this to it's over 2 hours now. Let's change this to this operator, the integer operator, and see what we have. Let's force this to type integer. Okay, it won't accept it. It won't accept it. But basically, what I could notice here is that basically the okay, let's do this. We have let's do this. Let's do to num1 so that we can see the difference. Num1 okay, no, num4 divided by num2. See what we'll have. Correct. I have num2. Oh, okay. Num1 divided by, then we change this. Oh, sorry. Okay, I didn't get num4. Okay, so I'll change this to num6. There was an error. I'm supposed to change this to num6, but I left it as num5. So let's see the difference between these operators, the modulus operator and the floating point operator. Let's see, this was num2, okay, num2 and num4, okay, num4 is this, so let's see what we have there. Okay, so we could see now that the modulus operator gave us what, 4.09, while the floating point operators gave us what, 0 point this. Okay, so let's change this to so we could see the difference there. Num2 modulus 4, it gives us the remainder. The remainder is 4. By the time you do this division, num2 is what? Num2 is 4.09. Then num4 is 5 point this. So the remainder of this division of this operation is 4.09. Okay? That is to say, by the time you find out how many 5 points, this statement here, this line 10 statement is saying how many 5.8 can you find in 4.09. Whatever the number is, whatever remains is 4.09. Okay, so let's use, we've been able to use then the normal what's it called now, the normal floating point division, where we say num2 divided by num4. Okay, so we have this as 0 point, this whole expression, this whole decimal place, when you put it together, it will give you this. Okay, all right, so let's go to okay, I may not be correct on that, my last statement here, but let's look at another example here with say the 3 divided by, let's say 2 divided by 5 here. We'll change, let's leave it at 6. Let's create another identifier num7, and we assign the value 5 to it, and let's see what the result will be. This is num7 divided by num2. Okay, and we are using the integer division operator, so we are changing it to this. So let's see what we have. We'll run this program. We are saying 5 divided by 2, that is how many 2 can you find in 5, or can be subtracted from the figure 5. Okay, like we did the other time. And let's run it. What do we have there? We have what, 1.0. okay, so 5 divided by 2 will give you what, 2, remainder 1. That is this one you're seeing here. Okay, so num2 modulus num4 is going to return the remainder. So 4.09 is the remainder, as we have 2 divided by 5, the remainder is what, 1. Okay, but if we change this to a floating point division, we could see that the result will what, change. What do we have? 1.22222. Okay, so this is the decimal, so 1 is the remainder. Okay, 1, 2, so this is the result. Okay, so you should know when to use the modulus, when to use the floating point division operator, and the integer division operator. So we are going to end this third tutorial here, and we'll do the third video, which will handle the aspect of logical operators and compound operators and logical operators. Or let's see if we can go ahead with the compound operators. I think let's go ahead with the compound operators. Okay, so that is another. Now these are the compound operators. Compound operators are two operators put together. Okay, two operators put together, and what we have here is the addition operator combined with the assignment operator, the subtraction operator combined with the assignment operator, the multiplication operator combined with the assignment operator, the floating point division operator assigned with the combined with the assignment operator, the integer division operator combined with the assignment operator. So let's look quickly how they work. Okay, because there are areas where there are times in your programming where you would use these operators. They are handy, especially in especially in addition, especially in multiplication, especially in summation. Okay, summation or subtraction, as the case may be. Okay, so if we still remember the concept of multiplication and subtraction and division, and then addition and multiplication, the repeated number of times that something has to be done, okay, a figure has to be added. Now when we say when we say this, when we say we let's look at 2, and we say 2 let's say 2 num2 is holding, okay, num1, let's use integer first. Num1 is holding the value 2, and we say 3. Okay, now what this simply means is that, let me take out this, num1, and I'm going to output the result here, num1. Let me take this off as well so that we don't module up things here. This is a compound operator, okay, where the addition operator is combined with an assignment operator. Okay, so two of them coming together is called a compound operator. Now what we want to achieve here is this. We want to add 3. We want to assign 3 to the memory location num1, okay, and as well carry out addition on it. Okay, so 2 operations will be done here. Okay, 3 will be added to the content of num1, then the final result will be stored in num1. That is what this operation will evaluate to. So let's do this. Are we seeing the result? 5. Now num1 was holding a value what? 2. Then we now an integer 2. Now we are saying the integer 3 should be first of all added to the content of num1. Whatever the result is, store it in num1. That is simply what this compound operator is all about. The integer 3 should first of all be added to the content of what? num1. Then the result of that addition should be what? Stored in what? num1. I'll give you a typical example what it is. Num1 is assigned the value 2. So num1 plus equal 3. What this simply means is that the computer, the interpreter or the processor is going to carry out this operation first. 2 plus 3. Okay, it will evaluate. 2 plus 3 will give us what? Will give us what? 5. Now what's the next what the processor will do next is that it's going to assign the value 5 to what? num1. Okay, it will first of all add the integer 3 to 2, because we know that num2 is holding this value. Num1 is holding the integer 2. So when we say num1 plus equals 3, it's simply telling the processor that, look, add the integer 3 to 2. Then the result, which is 5, assign that value, that result, to num1. That is to say, num2 will now be erased completely. Num1 will now carry the new result of the evaluation of what? 3 plus 2, which will give us what? 5. That is what this expression is all about, this compound operator. There are scenarios in your programming that you would want to accumulate a particular value, or carry out accumulation, that's carry out summation. Okay, it's necessary you do this. So instead of doing repetition, say 3 plus 3 plus 3 plus 3 plus 3, okay, like we did here. Okay, if we say, since it is associative, it's still, if you say plus sign is associative, multiplication sign is associative. That is, if you evaluate the right hand operand, okay, of the operator before the left hand operand of the operator, it will still give you the same result. If you start from the right hand part of the operator to the left hand part of the operator, it will still give you the same result. So addition is also associative. Okay, so let's look at the next operator, compound operator, which is this. So from our basic understanding, what this is simply saying is that the value 3 should be subtracted from the difference. The value 3 should be subtracted from 2, and the result should be stored in num1. That is what this is saying. And the result is going to evaluate to -1. So let's see what we have there. Good. Are we seeing it? -1. So if we go back again to this, what this other statement is saying here is num1, which is holding the value 2, okay, then num1 minus equal 3. This simply means 2 minus 3. What is the difference between 2 and 3? The difference between 2 and 3 is minus 1. Okay, 3 is greater than 2, So by the time you remove 3 from 2, you have what? Minus -1. If you're owing me 3 naira, okay, if you're owing me 3 naira, which is this, you're owing me 3 naira, okay, and you give me 2 naira, what will be remaining is 1 naira, so it's -1. So you're still owing me 1 naira. That is why it evaluated to -1, because 2 minus 3 is going to evaluate to -1. The best explanation I can give. Okay, so we've been able to see how the second compound operator works. Let's see for multiplication. Okay, so it's also the same thing here. What it will do is that it's going to multiply 3 by 2, then the result will be stored in what? The result will be stored in num1. So that takes us back to the initial evaluation we did with respect to this. Okay, if we change num1 to 3, so we could see another, let's change num1 to 3, then we change this value to 5. So let's see what is going to evaluate to. The result will be 15. So this is another way of writing 3 times 5. This is another way of saying num8, a new identifier. If you say 3 multiplied by 5, okay, let's also print out this statement there, which is num8. These are practicals, hands-on programming practicals. As you teach, you see what it's evaluated to. Okay, so let's see what the result will be at the end of the day. Okay, so we see is 15. So another way of writing 3 times 5 is what? Num1 compound operator assign 5. Are we together? So num1, which is holding the value 3, you're saying that 5 should be multiplied by what? 3, and the result, whatever the result is, it should be assigned to num1. Okay, these two statements are going to evaluate to the same what result as we are seeing here, 15, 15. So I believe with this we've been able to grasp the concept of a compound operator, where you bring an addition operator and an assignment operator together. The addition operator, which is in front, or the operators that are in front, will first of all evaluate. Okay, when it evaluates, then it would once it evaluates, first of all, addition will be done before the assignment part of the operation will be done. Subtraction will be done before the assignment operation will be done. Multiplication will be done before the assignment operation will be done. Floating point division will be done before the assignment operator will be done. Integer division operation will be done before the before the assignment operation will be done. I hope this is clear enough. Okay, so if we change this to change num1 to 5, then we change this value here, this integer, since we are working with floating point, So let's change this to num4. This is num4. Then we change this to num2. Say num2. Okay, so we are going to look at the results. Okay, we'll also do this and we'll see that it's still the same result that we'll have. Divide by num2. Okay, okay, so what we have here is what are we having? That's num4. It's 5.8. num2 is 4.8. Okay, so what we have here is I didn't mix up anything.